What's up, kings and queens? Happy Tuesday. Welcome to a brand new week. I hope that you guys enjoyed your long weekend. Now, let's jump into Unit 1, Lesson 4b. Once again, today is Tuesday, September 29th, 2020. So, we want to make sure that our notes are dated as such. And we are taking notes today on page 8 of your spiral notebooks. As usual, our classroom norms are that your cameras are to be on, your mics are muted, unless you're speaking, of course, and that you guys are ready to learn and chat. Today, you will need your Math 7 Spiral notebook, a pencil, and also the student companion for Lesson 4b that is found in Google Classroom. So once again, we're in day 2 of equations for proportional relationships. So once again, we're talking about representing proportional relationships with equations. As you can see on the screen, we talked about this last week, but remember, our format for constant of proportionality is y equals kx, and k is going to be your constant of proportionality or your unit rate when we're talking about equations. So let's go ahead and copy this first section down. Today's standard is going to be 7.rp.2c, and our objectives for today are students will use the word reciprocal to explain orally and in writing that there are two related constants of proportionality for a proportional relationship, and also write two equations that represent the same proportional relationship. For example, y equals kx, which we just talked about, and x equals 1 over ky, and explain what each other means. Our mathematical practices for today are MP2, which is reason abstractly and quantitatively, and MP8, which means look for and express regularity and repeated reasoning. So as usual, we want to make sure that we're ready to take notes and work collaboratively with one another. So let's pause the video here so that you guys can copy down your standard and your objectives. Moving right along, let's jump into our engagement for today. Our engagement, we're going to spend some time actually copying this into our journals. So our engagement is entitled Squares and Circles. It says each table represents a proportional relationship. Remember, a proportional relationship is found using our constants of proportionality, and that's easy to find because we know how to find the unit rate. So once again, it says for each, find the constant of proportionality, meaning your unit rate, and write an equation. Our equation is going to be of the form something y equals kx, or we're going to use the actual variables that are used in our table. And we want to write an equation that represents the relationship. So let's pause the video here so that you can finish copying down these tables into your notes and see if you can figure out what the constant of proportionality is and the equation. Now that you guys have had some time to work on this independently, can you guys go ahead, somebody unmute and share what you found to be the constant of proportionality for the first question and what your equation is? And then after that person shares, I want your classmates to respond in the chat whether or not they agree with that answer. So now that you all have shared, hopefully you realized that for the first table, your unit rate or your constant of proportionality was 4. Because if I look at the second column, all of these are just increasing by multiples of 4. So for 2, I have 8. 3 times 4 gives me 12. 5 times 4 gives me 20. 10 times 4 gives me 40. I multiplied all of my values for S by 4 to get the values in the P column. So your equation should have been P equals 4S, or 4 times S, because we multiplied everything in the S column by 4. So your equation was P equals 4S. If you wrote it in the form y equals kx, then it would have just been y equals 4x. So either one of those is acceptable. So let's pause the video once again, and I want somebody to share what was their constant of proportionality for the second table, which was a little bit more difficult, and then see if you can come up with the equation. Now, hopefully you realized in the second table, your constant of proportionality was 3.14. So all I had to do was divide this first column by 2 to get my unit rate. So for 1, it would be 3.14. And again, I'm multiplying everything in this first column by 3.14. 2 times 3.14 gives me 6.28. 3 times 3.14 gives me 9.42. So your constant of proportionality for the second table was 3.14, and your equation was C, the second column. So C equals 3.14D, because D is representative of the first column. Remember, we multiplied everything in the first column by 3.14. So once again, your equation was C equals 3.14D. Now, let's take some time looking at what our goals are for today. So, the first thing that we want to be able to do by the end of class is find two constants of proportionality for a proportional relationship. And you also want to be able to write two equations representing a proportional relationship described by a table or story. So, let's do some investigating, okay? Let's investigate the equations that represent proportional relationships. We want to investigate the equations that represent proportional relationships. Now, let's move to the explanation portion of our lesson. At this time, you are going to need to access the student companion in Google Classroom so that we can complete the activity. Remember, in order to get credit for the live lesson, you have to be also present in class and also completing the student companion. So let's make sure that we have that open, and let's keep moving forward. So on the second page of your student companion, you should see a set of tables with the explanation title, meters and centimeters. So the student companion says there are 100 centimeters in every meter. So instantly you should recognize this first row in our first table where there's 100 centimeters for every 1 meter. This is our constant of proportionality, or our unit rate, meaning that for everything in this first column, I should be able to multiply it by 100 to get everything in the second column. For instance, 1 times 100 gave me 100. So number 1 says to complete each of the tables and find the constant proportionality. Well, I just told you what the constant proportionality was. So now we want to be able to complete the table. So let's take a second for this first table. Let's take about a minute and 30 seconds now that we know that we have to multiply every single thing in this first column by 100, because this first row gave us our unit rate, or our constant of proportionality, to figure out what the rest of the numbers are in this table. So let's pause here and see if we can figure out what goes in the rest of the first table. Now, let's double check our answers. So, can somebody go ahead and share out what the values are that they got for the rest of the first table? And then in the chat, I would like for our classmates to agree or disagree, and then we will come back together and check our answers. So, now that we're ready to check our answers, the first number for 0 and 94 hundredths, the length in centimeters would have been 94. For 1.67, the missing value in the table would have been 167 because 1.67 times 100 gives me 167. 57.24 times 100 would have given me 5724. 5,724 would have been my value in the table. And then for this one that's labeled X, well, we've already established that I must multiply everything by 100. So the value that's missing would be 100X. Now, if you notice in the second table, things are a little bit backwards. It says there's 100 centimeters in 1 meter, but 100 is listed first. So in order to go from 100 to 1, I had to divide everything by 100. 100 divided by 100 is 1. That's how I got the value in the second part of the table. So now that I know that this is my new unit rate or constant of proportionality, I need to divide everything by 100, or you could always multiply it by 1 over 100 or 0.01. They're all equivalent values. But to get from 100 to 1, I had to divide by 100. So let's take some time now to figure out what the missing values are. Okay, so let's check our work. So for 250, the length in meters would have been 2.5. For 78.2, the length in meters would have been 0.782. For 123.9, the length in meters would have been 1.239. And then for y, the length in meters would have been 0.01y. 0.01y. Okay? So, how can we find an equation for each table? Well, we can do that using the constant of proportionality. Okay? So, looking back at my student companion, the constant of proportionality for the first table was 100. And then for the second table, you should have noticed that you could have did 1 over 100 or 0.01 for your constant of proportionality. So your equations would have been y for the first table, y equals 100x. And then your equation for the second table would have been y equals 0.01x. And then if you noticed, it says, what is the relationship between the two constants of proportionality? You should notice that the constant of proportionalities are reciprocals of each other. And all that means is that if I have 100, the reciprocal of 100 would be 1 over 100. I just flipped the fraction. So those were the two things that I noticed. The constant of proportionalities were located in the first row of my tables, and they're reciprocals of each other. So let's do some deeper digging. Okay, let's go ahead and talk about this next slide. It says the constants of proportionality are reciprocals. So again, if I have the equation y equals 100x, the reciprocal of it will be 1 over 100. Okay, if I multiply both sides of that, I get the other equation. So when I multiply both sides by 1 over 100, it gave me some additional things to find a separate equation. So if you are trying to give the length in meters, if you're given the length in meters and you want to find the length in centimeters, you're going to multiply the number of centimeters by 100. So that's represented by this first equation at the top. So if I'm given the length in meters, which will represent x, and I want to find what it would be in centimeters, I would just multiply it by 100. So that was representative of the first table that we had on our student companion. The second equation where it says x equals 1 over 100y represents if I'm given the length in centimeters and I want to find the length in meters, I'm going to multiply by 1 over 100. Remember, this is where we divided by 100 because dividing by 100 or multiplying by 1 over 100 is the same thing. Now, let's jump into our elaboration activity on our student companion, and it's going to be entitled Filling a Water Cooler. It says it took Ari 5 minutes to fill a cooler with 8 gallons of water from a faucet that was flowing at a steady rate. Now, we want to let W be the number of gallons of water in the cooler after T minutes. So there are 3 questions here that we definitely want to make sure that you're answering. So let's start working and be prepared to share your thinking with the class. So we're going to pause the video here for about 3 minutes, and based on the prompt that was given to you and your student companion, let's try to answer these 3 questions, and then we'll come back together so that we can share out. Now, let's go ahead and share out some answers. I'm going to read the prompt one more time. And as I'm reading, I want you guys to put in the chat what you think the answer was for number 1. It said it took Ari 5 minutes to fill a cooler with 8 gallons of water from a faucet that was flowing at a steady rate. We're going to let W be the number of gallons of water in the cooler after T minutes. So again, as I'm talking and we're checking our work, let's put your thoughts into the chat. So hopefully you realized that there was more than one answer for this problem. So both W equals 1.6T, which was your first option, and T equals 0.625W, which was your last option, represent the relationship of W and T. So again, these are reciprocals of each other if you were to simplify 8 over 5 and 5 over 8. This first option and the last option were your answers. Okay. Number 2 says, what does 1.6 tell you about the situation? So 1.6 tells you that water is flowing at 1.6 gallons per minute. So again, we wanted to do that division of 8 gallons over 5 minutes, and I divided to get the unit rate or the constant of proportionality. So when I did 8 gallons over 5 minutes, when you divide 8 over 5, you get 1.6. And once again, 1.6 tells you the water is flowing at 1.6 gallons per minute. Okay? Now, it says, what does 0.625 tell you about the situation? 0.625 tells you that it takes 0.625 minutes for a gallon of water to flow out of the faucet or into the cooler. So again, this is just a reciprocal. If I do 5 minutes divided by 8 gallons, I know that it's going to take 0.625 minutes, which is less than 1 minute, just to get a gallon of water. All right, let's keep moving and let's see if we can answer number 4 and number 5. Once again, we're going to let W be the number of gallons of water in the cooler after T minutes. Number 4 says, RE changed the rate at which the water flowed through the faucet. Write an equation that represents the relationship of W and T when it takes now 3 minutes to fill the cooler with 1 gallon of water. If it takes 3 minutes to fill the cooler with 1 gallon of water. So let's pause the video here and see if you can come up with your new equation. Remember, we usually write things in terms of y equals kx, but this time we're going to use the variables W and T. Remember, W represents gallons of water, T is time. So you can either write an equation starting with W equals or starting with T equals. Let's pause here and see if you can come up with the equation. All right. So there were two options for equations. So if I wanted to start with time, we can say T equals 3W because it would take 3 minutes for however many gallons of water, which represents W. Or you could have did the reciprocal and have gotten W equals 1/3 T. So T equals 3W or W equals 1/3 T. Now, let's look at number 5. It says, was the cooler filling faster before or after RA changed the rate of water flow? Explain how you know. So let's take two people to unmute yourselves and tell me, based off of the last problem that we just did and then number 4, was the cooler filling faster before or after RA changed the rate of water flow? And then tell us how you know. Thank you so much for sharing. So now, just to solidify the answer, the cooler filled faster before RA changed the rate of water flow. Remember, before the change, it took only 0.625 minutes to get 1 gallon, but after it took 3 minutes to get 1 gallon. Okay. So, also, if you compared it alternatively, before the change, she got 1.6 gallons per minute, but after the change, she only got 1/3 of the gallon per minute. So, once again, before the change, it was faster. So, once again, here's our vocabulary word wall that is going to be updated for you guys as a reference. I will also put this in Google Classroom. Now it's time for our evaluation. Your evaluation is going to be done on your own because, again, we're completing the student companion. So let's look at our evaluation in our student companion. And it is entitled Flight of the Albatross. So let's read the prompt. It says, an albatross is a large bird that can fly 400 kilometers in 8 hours at a constant speed. Using D for distance in kilometers and T for the number of hours, an equation that represents the situation is D equals 50T. So it already gives us the equation. Number 1 says, what are two constants of proportionality for the relationship between distance in kilometers and number of hours, and what is the relationship between the two. Hopefully, you remember we've been talking about reciprocals. So, looking at that equation of D equals 50T, once again, I'm reading from the student companion. Looking at D equals 50T, one number there is given your constant of proportionality. To find the other, we just need to take the reciprocal of it. Then number 2 says write another equation that relates D and T in this context. In order to do that, I'll go back to what we said earlier. Let's go back a few slides. Remember, we had this first equation, and then we rearranged our variables with the reciprocal to find the second equation. So in number 1, one of the constant of proportionalities was given to you here that you want to label, and then the reciprocal was there. And then we rearranged our equation to find the new one in that context. So let's go back to our evaluation questions. Let's pause the video here and take about 2 minutes to answer these on your own. Now that you've had some time to answer those, let's close for today and talk about what is expected of you moving forward. So, You got it. There is a quiz that is going to be coming very soon, like today. So, today's recap, this was day 2 of our lesson with proportional relationships and equations. So, the first thing that you need to do for your independent activity is to submit the student companion today. It is extremely important that that is submitted in order to get credit. If it is not submitted, you will not get credit for today's lesson, which should be easy because we were recording our answers as we went through the presentation. The second thing that you guys have to do, and remember, tomorrow is Wednesday, so we do not have class. We'll meet again on Thursday. Your quiz is going to be on Big Ideas workbook page 110, numbers 1, 2, 3, 4, and 6. So you're skipping number 5 and number 7. Once again, you are skipping number 5 and number 7. You are only completing 1, 2, 3, 4, and number 6. This is going to be your quiz for this topic. So, if you already have picked up your workbook from the school, you can go ahead and complete the work in your journal and upload a picture of it to Google Classroom. Or if you do not have the workbook, I'm going to copy a set of picture or the picture of the workbook page and put it as an attachment in the Google Classroom assignment. So if you do not have the workbook page, you can look at the problems on Google Classroom and just complete it on a separate sheet of paper. And then you can also upload a picture of your work. This is due on Wednesday at 11:59 p.m. So you have tonight, which is Tuesday, to work on this, and also tomorrow to get these 5 problems done. Now, in order to help you a little bit more, because I know that these topics can be a little bit difficult, I have put a few short 1 to 2 minute videos to help you study and answer these questions for your quiz so that everybody can get a passing grade. So, again, I recommend that between now and tomorrow, before you complete the quiz, that you watch the 3 videos that I'm going to post in Google Classroom. Now, once again, those videos are going to be no longer than 2 minutes each, and you can watch those before you complete those 5 problems. Once again, you're completing the student companion today and putting that and submitting that in Google Classroom. And then lastly, the quiz, which is going to be based off of Big Ideas workbook page 110, is due Wednesday at 11:59 p.m. Other than that, I hope that you guys have a wonderful rest of the day. You can take this time to say goodbye to your classmates, ask any questions that you may have to Mr. Spencer, and you guys are released, and we will see you again on Thursday. Have a great rest of your day.